We all love our noise-canceling headphones, but let's be honest, they've got this one huge, annoying flaw. Today, we're diving into some really cool research that shows a pure software hack can supercharge the headphones you already own to get you that perfect, uninterrupted silence. It's the ultimate first world problem, right? You spend a bunch of money on these premium headphones, you flick the switch, and the world is supposed to just melt away. But you can still hear every single word of your coworker's phone call. Why is that? Well, that is the exact question we are going to unpack today. All right, so here's our game plan. First, we're going to define the problem, what we're calling the ANC sound gap. Then we'll get into the science of why it even happens. After that, we'll reveal this really clever software solution, break down the tools it uses, see how it's built to be super efficient, and finally, check out the amazing results when hardware and software team up. Okay, let's start by giving this annoying problem a name. The researchers call it the ANC sound gap, or spectral leakage, and it's not a bug or a defect. It's actually a fundamental limit of the hardware itself. This right here lays it out perfectly. Active Noise Cancellation, or ANC, is absolutely brilliant at killing those low, constant drones, like airplane engines or the hum from an AC unit, but it totally struggles with sharp, sudden, high-frequency sounds, a category that, you guessed it, includes human speech. So to really get why this gap exists, we've got to do a quick dive into the physics of how your headphones fight sound with more sound. At its core, this is what's going on. ANC isn't about blocking sound like earplugs. Nope, it's actually creating an anti-noise sound wave to literally erase the sound wave you don't want to hear. It's a process called destructive interference. And this is the process in a nutshell. Step 1. A mic on the outside of your headphones listens to the noise around you. Step 2. A tiny computer chip inside instantly flips that sound wave upside down. 3. Your headphones play this new anti-noise wave. And finally, 4. The original noise and the anti-noise meet, and poof, they cancel each other out. Silence. But here's the catch. That little computer chip, the DSP, is fast, but it's not instantaneous. There's a tiny, tiny delay, what engineers call latency. For a low, predictable hum, this is no big deal. But for a high-frequency, unpredictable sound like a human voice, the chip just can't react fast enough to make a perfect anti-noise wave. That is the leak. That's the gap. So this brings us to the really clever part. The engineers basically said, okay, if hardware limitations mean we can't cancel the sound, what if we just mask it instead, using software? And this is the hero of our story, a research app called JBL SoundProof. Now, this isn't a replacement for your headphones. It's designed to work with them, adding a smart software layer on top of the hardware to finally plug that gap. And this is the whole new strategy. Sound masking. See, instead of trying to create perfect silence, the idea is to add a soft background sound, just enough to raise the floor, so to speak, so that distracting noises like voices just kind of fade into the background. They become gibberish, and your brain can just ignore them. This little table sums up the whole thing beautifully. Hardware ANC wants to cancel sound to create silence. The software masking, on the other hand, wants to mask sound to create privacy. And look at their strengths. They're a perfect match. One handles the low rumbles, and the other takes care of the high-pitched chatter. So, what sound do you actually use for this masking? You can't just play anything. The research points to one perfect candidate for the job, something called pink noise. Now, you've probably heard of white noise, right? That harsh, static sound. Well, pink noise is its cooler, calmer cousin. While white noise is a bit aggressive, pink noise is tweaked to sound more natural to our ears. It's less tiring to listen to, kind of like a gentle waterfall instead of an old TV with no signal. And as the author of the research paper puts it, it's psychoacoustically preferred. That's the key phrase right there. It just works with our hearing, not against it, which makes it the perfect sound blanket to throw over those distracting voices without becoming a distraction itself. Okay, so we're going to play this pink noise through our phone. Simple enough. But the way this app does it is incredibly smart, specifically to make sure it doesn't just destroy your phone's battery life. The app has 3 main parts. There's a connection manager that knows when your headphones are on, a service controller to keep it running in the background, and then, this is the really genius part, a signal engine that creates the audio from scratch instead of just playing a recording. So instead of having a big old MP3 file of pink noise saved on your phone, The app uses a fancy math formula, a stochastic signal generator, to create the sound in real time. Think of it like a video game that generates the world as you walk through it, instead of having to load a giant pre-made map. And the benefit of doing it this way is massive. The amount of processing power your phone needs just to play a normal MP3 is actually pretty big, but the power needed to generate the sound on the fly, it's practically nothing in comparison. It's wildly efficient, which is exactly what you need for an app that's going to be running all day. So, what happens when you put it all together? What happens when you combine the hardware's noise cancellation with this slick new software masking layer? While the results are fantastic, the hardware on its own is only really good up to about 800 Hz, but the software masking jumps in right where the hardware starts to struggle, covering everything from 500 Hz all the way up to 8,000. And together, this hybrid system gives you complete coverage across the entire critical range of human hearing. The ANC sound gap is officially closed. And that's really the big takeaway here. With a little bit of clever code, you can seriously upgrade the hardware you already paid for. You can fix its single biggest flaw and create that total bubble of silence we all thought we were buying in the first place. And the research doesn't even stop there. The paper suggests future versions could be even smarter, like using your phone's microphone to automatically adjust the masking volume depending on how loud your environment is. Or maybe even integrating directly with the headphones to control things like transparency mode right from the app. Which leaves us with this final thought. We started out just trying to block noise, but what this research really points to is a future that's much more powerful. A truly personal, adaptive silence that actually learns and adjusts to whatever world you're in. Can you imagine what that would be like? That is a very cool future to think about.